Bouquets might be the most difficult feature for the PyTorch, and not for PyTorch only, for NumPy as well. So then, let's discuss the thing about it. So the bouquets is using to enable the tensor with different shape to be added or to be modified together. So first it will align to the right, and it will try to explain the extension so that the size of both tensor will match to each other. And once the size of each dimension are matched, they can be add together. But there is some limitation for the broadcast. Not we the size of each dimension must be either the equal or one of the tensor is one. So for example, if we add a tensor whose shape is 2, 3, 1, we try to add it to a tensor which has only one dimension. So according to the right rule, the 3 will match to the right right side, right dimension. So the 3 will match to the third dimension of the tensor. And since the size of this tensor is 1, so we can just duplicate this one for 3 times to convert the 231 to 233, and then the 3 will match to the 3. Then this 3 will be expanded into the 113 here. The 113. So that the 3 will match to the 1, and by duplicate this one for 3 times. And it can, for the first dimension, you will duplicate 2 times. So totally you will have a 6 object. 6 of this object will be duplicated. So in the final, this one will become a tensor of 2, 3, 3, so that both sides can add together. And for the second case, okay, the dimension is the same. Both tensor has 3 dimensions, but the size of each dimension are different. So let's try to match it from the right. So this is 1, this is 3, so we'll duplicate this one for 3 times to make this tensor as 2, 3, 3. So 3 and 3 are the same, so we check the next one, 3 and 1. So this time this one is 1, so the 1 will duplicate for 3 times. In the same way, for the first dimension, this one is 2, this one is 1. So we'll duplicate the right side for two times. So in the final, both sides will become a 2, 3, 3. So the return tensor is 2, 3, 3. Okay. So that's how the bouquets is implemented. It looks quite complex, so that typically we will not using such a complex rule to do the conversion. We should try to do our best to make the shape of both tensor the same instead. Okay, so we can try to do some trial here. we create a tensor whose dimension is 2, 3, 3, and then we create another tensor which is a one-dimensional tensor, and there is 3 elements in the tensor. So that we can see that the shape of A is 2, 3, 3, and the shape of B is 3. So we can try to add A and B together and check the size. So obviously it's 2, 3, 3. Okay. And we may try to print out the result of A plus B. Okay, so we can see that when we add the B into the A, so it means that we will add a number. For the first column, we add 1, and for the second column, we add 2, for the third column, we add 3, which is the 1, 2, 3 here. Okay. And we can see that the 1, 2, 3 you duplicate for totally 6 times, so that it can add to the 2, 3, 3 tensor, which is the A. Okay, so that's the explanation of the broadcast feature for the NumPy and the PyTorch. Hope that everybody will understand the broadcast feature, so that when you see the broadcast using in your program, don't be surprised that we can add the tensor with different size together.